Welcome back to CTN. I'm Robert Van Sluten. This episode, I'm going to present some recursive graphics. Let's get started. I am running a single view iOS playground. The assistant editor is taking up most of the screen, which is referred to as a live view in this particular situation. Some code on the left-hand side, and the debug pane open. I'm going to be covering playgrounds in the next episode because they have a fair amount of usefulness and also some disadvantages. And then after that, we'll do some more recursion. Let's run this. The basic question to you is this recursive? And the answer is actually yes, because we have a left-hand lower triangle, a right-hand lower triangle, and an upper triangle. And within each of those triangles, there's a lower left, a lower right, and an upper triangle. Let's reduce the recursion depth to 3. Rerun the program. Takes a while because it's running on a simulator and also I am recording. So in this case, you see it a little bit better. The lower left hand, the lower right hand, and the upper triangle. Now this recursion is from bottom up. It's actually drawing the lower left-hand triangle first, then the right, and then the upper. And then it's drawing the lower left, the bigger one, and the lower right, and then the upper. Down on the debug pane, you'll see that only 27 lines are drawn because the outermost triangle is actually a result of the inner triangle. If you did a top-down recursion, you'd be drawing more lines because you would be drawing the outer and then the progressive inner. If I change the recursion level to 1, which is actually the stopping condition, rerun, you get a single triangle. So down on the bottom of the tree, the terminating condition draws a triangle. And in this case, only 3 lines are drawn. In actuality, this is actually a UI view, and what's happening is lines are being drawn in core graphics. And we'll take a look at the code in the next slide. The recursion function, embedded triangle, takes 4 parameters. It takes 2 points that represent the ends of the base of the triangle, a height of the triangle, which is a double, and a level, which is just an integer. The stopping condition actually draws a triangle. But what it really does is it puts the line information, the lines for that triangle, into an array. Later on, that completed array is used by a drawer function in the view. The actual recursion recurs 3 times. It actually generates the information for the 3 triangles that have to be drawn. Now, the fact that it generates an array separates the creation of the graphical data from the actual drawing process. Now, the points are a little different in the sense that I create a point of my own that I define in a line, which is simply the 2 points that form that line. The reason I do this is because I want to normalize the coordinate system. I want 0, 0 to be the lower left, 1, 1 to be the upper right, and normally in a UI view, 0, 0 is at the top left, and the coordinates are based on the size of the view. This separates the point system the graphical coordinates from the view characteristics. And I'll show you that in a minute. Down lower is the definition of the view and the drawer function, the overrid function, which you can do, but you can't call that directly, but that's another subject. And then down below is a setup of the view and its characteristics. And actually, we call a thing live view that we attach to. In the beginning, we simply get UI kit, which is actually put there for you when you create a single view iOS playground. And to get the live view, you have to import playground support. The one thing I didn't mention is in the fact of the point that I defined, there is a function that actually converts that point to the core graphics coordinate, which is based on the size of the view at the current time. Now, because I've separated the coordinate system, my coordinate system, from the UI views coordinate system, I can change the size of the dimension of the view. Let's say I go from 300 to 500. And I actually run this. The view size, it's a little truncated because I have to move this over, is changed, but the internal graphics, the drawing process, is the same thing. It has not been modified. Anyway, that's it. Let's move on to the photo. Okay, one thing I didn't mention is that the UI view is actually slightly bigger than the drawing area. And the reason for that is I want some border around the edges, primarily because I didn't want the lower lines to be right on the edge of the view. So there's a little bit of mathematics which enlarges the UI view slightly. That's it. Thanks for watching.